right, now that we've looked at some of the ways that water can be in the atmosphere and what happens with that water, one of the most important things as far as weather goes is going to be clouds or fog. This is one of the most obvious ways or the most visible ways that we see water in our atmosphere. We don't get rain unless we have clouds. We'll talk more about rainfall later on in this chapter. And so, yeah, the first thing, or not the first thing, but as we continue on here, we want to look at clouds. And clouds are when droplets of water or ice crystals are present in large enough numbers to be visible. They are floating in the air. Most often they are high up in the air compared to where we are. Most clouds result from adiabatic cooling of moist air. Remember, adiabatic cooling means that the air rises, and as it rises, the pressure is taken off, and the temperature drops. No heat is lost, but the temperature drops, and then the water droplets that are present in that mass of air actually condense around condensation nuclei, making, or freezing nuclei, they freeze around them, making these clouds visible. Now, we scientists have classified clouds based on altitude and type, and actually they've added a few types over the years as they realized certain effects on these, or that gave rise to these clouds. And today, meteorologists classify clouds into 10 basic categories based on shape and height. We're going to look first at low altitude clouds, and this section starts on page 241 in your book. These are clouds that have bases between the ground and 6,500 feet. Now, according to this definition, it would include fog. We're going to talk about fog later on, though. We're looking mainly at clouds that are up in the air. And the first one are cumulus clouds. They are white, billowy clouds resembling piles of cotton puffs with flat bases. And they're usually relatively high in the air above our heads. The cumulonimbus is the thundercloud, or the storm cloud of this. Keep that in mind. Nimbus, we'll be seeing that added on to other terms, and that usually means storm with it, that kind of cloud, and it's a storm cloud. Stratus, these are the types of clouds that often form a flat gray layer of heavy clouds not far above the ground. If you're wondering what these look like, we will look at some pictures here in a bit. And then the stratocumulus. These are the most frequent clouds. They're low, a heavier layer of puffy gray clouds. And I have some pictures here on the next page. There we go. If I remember right, going from the upper left is our cumulus clouds there. The upper right is the cumulonimbus. Remember I said that rain? You can see the rain falling down in that cloud, out of that cloud there. Lower left should be the stratus clouds. And then the right are the stratocumulus clouds there. Still kind of that puff ball shape, but they're flattened out, stretched out a little bit more. Continuing on with the types of clouds here, mid-range altitudes. These have bases between 6,500 feet and about 23,000 feet. And these include the nimbostratus. Remember that nimbus there. These look like stratus clouds, but they are much thicker. They block out any view of the sun or moon. Usually gray in color, bring steady precipitation. The leftmost picture here is our picture of this nimbostratus. Altocumulus, they look like cumulus or stratocumulus, but appear smaller from the ground. This is the one that's in that lower middle. And then altostratus, flat sheet-like clouds that look similar to stratus clouds, except they are lighter in color. And you have this nice ocean view picture there with the stratocumulus clouds, or altostratus, clouds. And as we move to our high range altitude clouds, these have bases between 16,500 feet and 40,000 feet. So there's a little bit of crossover there. These include cirrus clouds, which are the far top left there. Most common type of high altitude clouds, and completely made of ice crystals. They're so high up that the water not only condenses, but it freezes. They form thin streamer of clouds that look like feathers or horsehairs. They were also called mare's tails back in the day because sailors looked at it, or rather people looked at them, and it resembled what a horse's tail might look like. Cirrocumulus in the middle there look like tiny puffs of cotton in the upper troposphere, high up, much higher than the other ones that we've talked about. And then cirrostratus, all the way on the right, thin, translucent clouds that spread like a sheets. So they spread out more, a little bit stretched. So, and then we have some special clouds. These clouds form under some specific characteristics as that aren't common in every part of climate here. And the two our book mentions are lenticular and contrails. Lenticular clouds are almond-shaped clouds, often form above mountains. And I've actually seen pictures of 3 layers. I believe this is a picture of Mount Rainier, if I remember right, with 2 lenticular clouds above it. Has to do with that rising air hitting certain altitudes, with the thinness and stuff, the effect that the mountain has on the air around it, so we get those lens shape. That's actually what lenticular means, shaped like a lens. And then we get contrails also. These are long, narrow clouds formed from an airplane's jet exhaust. These contrails didn't exist until we got planes up in the air. And, where'd it go? There it is. These are artificial clouds. They just form because of the plane traveling through the air there. The jet exhaust quickly condenses and freezes into ice crystals. If the surrounding air has a low relative humidity, the ice crystals will quickly become water vapor again. So you can actually get a general idea of how humid the air is depending on how long contrails stay around. If there's a lot of humidity in that upper atmosphere, those contrails will stay around for a long time, probably a couple hours or so. If there's very little humidity, the contrails will disappear very quickly, several minutes. So that's one way to gauge how much moisture is in the air. Now, it's not a perfect estimate, but it gives you a rough idea of just how moist it is up there and how likely it is that we're going to get some rain. Ignore this one, because we're going to go straight to the fog. I put that slide in the wrong spot. Sorry about that. Fog, remember we said that low altitude clouds were from the ground up to a certain altitude. Fog does fall into that, but generally speaking, we don't consider fog a cloud because it is right against the ground. When water vapor condenses in the layer of air near the ground, and it's only considered fog if visibility is less than 1 kilometer. And it's 1,000 meters, and that's roughly, well, it's a little over 3,000 feet. And mist if the visibility is greater than 1 kilometer. So, just the differentiation there between fog and mist. And there are actually several ways of describing fog. Kind of depends on different things. How it's formed is probably one of the most common ways that they are categorized. Let's see, the first one you have here is radiation fog, when the ground quickly radiates heat back into space and a thick layer of air near the ground may cool below the dew point. Remember, the dew point was that temperature at which the moisture in the air will condense and form dew. Now, if there's nuclei causing droplets to form around condensation nuclei, if there's dust in the air or anything that it can form around, we get that fog. Oftentimes, that's radiation fog. So that you might find that in a forest area. It rains, lots of moisture, but then it cools off quickly. That moisture is in the air, and it forms fog. Shallow fog is radiation fog that does not extend over 6 feet above the ground. So shallow fog is just really low lying. A tall person might actually be able to see over it. And so, yeah, the shallow fog. A type of shallow fog is a valley fog. It's a radiation fog found in valleys during the night. The cold downward flow of air from the surrounding mountains cools valley air that is moist due to streams and rivers. Actually, that's not a shallow fog because it could be over 6 feet, but the type of radiation fog there. Another type of fog is the advection fog, formed when a warm, humid breeze blows over a cold surface, such as moist air from a river, lake, bay, being blown over the colder land, forming fog. That would be advection fog. When an advection fog forms over cold ocean water, it's considered a sea fog. England's well-known fogs are often sea fogs that develop from warm, moist winds encountering the cool waters around Great Britain. So, some things about advection fog. An upslope fog is formed when a moist wind blows up a gentle slope. As that moist wind goes up the slope, the air temperature drops as it gains altitude. eventually reaching the dew point or below the dew point. We get fog up a hill, basically. And then steam fog, when water evaporates and then encounters cold air. Sometimes warm rain falling into cool air evaporates, producing what's called a frontal fog. There's also freezing fog. If fog develops in air that is below freezing, the water droplets will become supercooled, resulting in freezing fog. When that freezing fog hits surfaces, the water freezes around those surfaces, which can be dangerous if you're driving and the surface is the ground. So something to watch out for. In some areas where the ground temperatures drop below negative 29 degrees Fahrenheit, water vapor in the air near the surface turns into ice crystals that remain suspended. And that's called ice fog, when it's actually ice suspended in the air. Now, there is a type of unhealthy fog back in the 1800s when factories were becoming more prominent. That's a smog, a mixture of smoke and fog. The smog we encounter more nowadays is not so much a mixture of smoke, but it's a photochemical smog, a thick brownish haze that results from complex molecules released in the air by cars, factories, certain trees, and other plants. So some of those things that contribute to photochemical fog are naturally occurring, but really it doesn't get bad until we look at cities. And we have a picture here of in the bottom left of L.A. looking down from one of the hills, and it's the difference between a smog and a fog is a smog is usually not gray; it's brown or orangey color, whereas a fog is that gray-white color, such as in the picture on the right. On the right, we have a fog over San Francisco. See the Golden Gate Bridge poking out there. So there are some areas that are kind of known for their smog. LA is one. Beijing is another. When the Olympics were in Beijing a few years ago, there was some concern since it was the Summer Olympics, for the marathon runners. And there were actually several top marathon runners that did not go to Beijing in the Olympics because they were afraid of the smog adversely affecting their health. Now, when the Olympics did happen, it had rained for at least one day, maybe 2 days before the marathon event, and as a result, the air got cleaned out. It ended up not being a worry for the marathon runners that did participate in it. So, smog is something that we do not want. I mean, it is unhealthy. It does not help in any way, shape, or form. And, it's generally associated with large cities, especially those surrounded by mountains, which prevent the smog from dispersing. It is rarely a problem in rural places. Every now and then you might hear about something in a more rural setting, but it's not that big of a deal usually. So this is section 8.2. Don't forget to do the science video question at mrmarks.com. So I will see you in class.